All right, ladies and gentlemen, moving on to example 6. We're using a table to find conditional probabilities. In this case, you're working at a factory, just meaning that something's being made where you are. Every time something's made, it's either going to work or it's not. Nothing's perfect. Sometimes you could do the same thing over and over and something on that equipment just didn't work right. Something got overloaded, it shifted as it was being manufactured, just different stuff, which we call that defective. When something is made but doesn't work, it's defective. And then when something it does work, it's called non-defective. We can refer to it as that. Now, this could change per company, but this is typically language I've seen. So here, you're an inspector. See, companies actually do this. They run the stats. They sit there and say, okay, if we randomly select an item, and what should be the likelihood that it doesn't work? And if we fall within that range, then this number should be working. It's also one of those things that companies kind of have to accept that they're going to ship some things that don't work because you can't test everything you make. Period. Not to the standards to be able to say it's going to be great, because by the time you're done testing, a lot of times it's no longer going to work, or it's not going to work as long. So anyway, what they do is they randomly choose one of the items being made, and they test to see if it works or not. And there's a lot of testing that goes into it, like there's endurance testing, there's all these different things that say, yes, it falls within what we're trying to make. Defective means it doesn't pass those tests. And non-defective says that it does pass those tests. And sometimes there are non-defective items that fail the test. Or I guess technically, yeah, non-defective items that fail the test, and there's defective items that pass the test, meaning it was working. Let's say non-defective that fails is the idea that it was working, it was the test itself that caused it to fail. So anyway, lots of weird ways to be able to read through this table, but essentially all this means is there are some items that don't work that will be shipped, and there are some items that don't or do work that won't be shipped. So if we did this as far as calculation, the idea is what's the probability that we would ship a defective item versus the probability that we would throw away a working item. That's what non-defective fail is. Non-defective fail means that we randomly took it off expecting it to be defective, but it actually was working. Sometimes I got to let my brain turn on. All right, so with all this, we're going to find the probability that a defective part passes our tests. So a defective part passes 3 times but fails 36 times. Now, again, that doesn't mean the test itself. What it means is it passed through inspection and got shipped. So what this really means is the defective part got shipped, meaning it got passed 3 times, but the defective part failed, meaning it got caught. It did not get shipped 36 times. And they know that because they get feedback from a store, because a store customer buys it and the store goes, hey, we got to return this, it's defective. Okay. So a defective part passes, and that happened 3 times, and the total number of times that there was a defective part was actually the 3 plus this 36 or 39 times. So that's the total amount of defective. So this becomes 39. Well, 3 over 39 can be simplified to 1 over 13. And 1 over, I don't know why I had another one here, so let's go ahead and get rid of that. 1 over 13 is about 0.077 or 7.7%. So there's a 7.7% chance that we had a defective item shipped out. Now, on the flip side of that, we want to check to see the probability that a non-defective item was thrown away. So we had 11 items thrown away that were non-defective, and we got to add the 450 and 11, so that's 461. So 11 out of 461. And again, I have an extra spot here, so I can just do that. And that's about 0.024 or 2.4%. Now here I'm not going to look at it, and we're technically not even asked to analyze, but what this tells me is we're actually more likely to ship a defective item than we are to not ship a working item, because the percent of probability that we will ship we will not ship a working item is 2.4%. And the probability that we will ship a defective item is 7.7%. 7.7 being greater than 2.4, we are less likely, lesser number, we are less likely to throw away a working item than we are to ship a non-working item. I think I switched that before, but that one's correct. All right, there we go.